And welcome back to Chemical Feud, where today we'll be asking 3 contestants some questions about the combined gas laws. Let me introduce myself. I'm your host, Dom Beto, and here are the 3 contestants here with me. What's your name and occupation?
My name is Stefan Mirza and I'm a doctor.
What's your name and occupation? And what's your name and occupation?
I am Jason and I'm an engineer.
Alright, now let's start with you. Why did you come onto the show today?
Well, see, I'm here. I would like to test my knowledge on chemistry. I've always had a thing for chemical formulas and what such.
Okay, I like
Yes,
that answer.
of course.
Alright, now let's move on. Why are you here today?
I need to pay off my family debt.
Okay, that's a respectable answer because there's a big prize here. $10,000, let me tell you. And you, why are you here?
I always liked chemistry and I wanted to test myself on this big show that's really popular.
All right. Now let's get it going to the rest.
And boil 3 tablespoons of water until steam is pouring out the top. Remove the bottle from heat and place a hard-boiled egg at the opening. To speed up the reaction, you can also place the bottle in cool water. The air on the outside will slowly push the egg into the bottle. Normally, if you were to place this egg on the opening of the bottle, the air molecules on the inside of the bottle will hit the egg and exert a force upward. At the same time, the air molecules on the outside of the bottle will hit the egg and exert a force downward, so nothing happens to the egg. But when you fill the bottle up with steam, it pushes all the air molecules out. Now, when you place the egg on the bottle and remove it from the heat source, the steam condenses back into water, leaving nothing to exert a force upward on the egg. And this allows the air molecules on the outside to push the egg into the bottle.
So before we get started with the first question, I need one of you to explain to me, what is the combined gas law?
Well, Mr. Beto, the combined gas law shows the relationship between pressure, volume, and temperature of a gas. It helps predict the gas behavior.
All right, thank you. Now let's get going. To begin, our first question. A gas has an initial pressure of 2.0 atm, a volume of 3.0 liters, and a temperature of 300 Kelvin. If the volume expands to 5.0 liters and the temperature increases to 400 Kelvin, what is the final pressure?
Stefan, 3 ATM.
Survey says? Bow.
Yes, sir. 5 liters.
Survey says? And Jason?
1.6 ATM.
All right, now Jason, can you explain how you got that question
Well, of
right?
course. May I take the stage, Mr. Beto?
Yes, of course.
Well, first, you start with our formula of the combined gas law, and then you plug in what we know. We know the pressure, the volume, and the temperature at the beginning. And then at the end, we know the volume is 5 and the temperature is 400. So then, with some basic algebra, you can find what this pressure, the predicted pressure is, and it's 1.6 ATM.
All right, thank you. Now it's your turn to try a problem. A gas occupies 6.0 liters at a pressure of 3.0 atm at a temperature of 290 Kelvin. If the pressure decreases to 2.0 atm and the temperature increases to 350 Kelvin, what is the final volume? Survey says, if you got 10.86 liters, you'd be correct. And thank you for watching Chemical Feud, and we'll be back with a new episode soon. Thank you.